Hello and welcome back to the Blade of Acquire channel. You are watching Shenzhen IO and we are now moving on to new things. So in the last one, we did the aquaponics maintenance robot and the haunted dolls. So let's move on. So I think the next thing is we got an email. Rare Earth Advisors, we are contacting you about an incredible once-in-a-lifetime opportunity to own land rich in rare earth metals in the western region of China. What are rare earths? Rare earth metals power the world's electronics, phones, engines, motors. It's fair to say the world would not run without them. But the world's supply of rare metals is drying up. Mining companies can't refine them fast enough to meet demand, and now the mining firms are looking to expand. Now is the time to own this land before the mining firms find it. So that's from the Rare Earth Advisors Realty Co in Miami, Florida, who are touting land in China. I find that highly improbable. Anyway, let's move on to the next design, remote kill switch. And we've got a communication from Xi. I would like to have a remote kill switch for autonomous systems, robots. This is in case of failure of the autonomous system. Of course, such a switch would not be needed if we always design the system correctly. There's a little sly dig there. We should make this. I will create the transmitter and you will create the receiver. Okay, let's have a look at this. So it's an RKS D1. Let's open the design. Right, so we've got RXTX unit. I'm not going to explain Radio RX because we've done that all day long. Power 0, Power 1 and Power 2 are simple outputs connected to high power switches that control industrial equipment. When a data packet is received over the radio, read it and execute the corresponding command in the following table. -1 is a keep alive, 0 is a power off, 1 is a power on. Turn off all power outputs when 5 or more time units have elapsed without receiving a data packet. Okay, there's a little extra condition there. So no data, turn everything off. Okay, so right. Okay, let me go back to this. Yeah, neg1 is a keep alive, right? So we get these neg1s coming in every now and then, which says don't do anything basically, and then we get a two piece of data packet. So we got a 1 and a 1. So the first value, it looks like, yeah, the first value is the instruction, and the second value is to which power output we're sending the instruction to. Right, let's slap one of these down to get started, and let's shove that in there, and then we're going to... Are we going to sleep on this? Is sleeping relevant on this? Because these things pump out all the time, don't they? It's non-blocking, isn't it? So... I could say forget that. Test equal right, I'm gonna have to have some kind of count in the accumulator that says if this is basically if x0 is equal to -999, and then we're going to do, if that's the case, then we're going to add 1. Okay. Otherwise, we're going to set the accumulator to 0. Okay. Right down here we need a sleep 1. and then if we hit, if I just turn this on its head, okay, so if we don't receive a 999, then we're going to reset the accumulator to 0. Otherwise, we're going to add 1 to the accumulator because we're going to start our timer, and then we're going to jump to I guess check, and then in check we're going to say test equal ac test greater than ac 4, right? So if the accumulator is greater than 4, i.e. it's 5 or more, then we are going to do something else. We are going to shut everything off, aren't we? Turn off all power. So now the power is literally, yeah, it's like on or off, so there's no power level, so we can get away with using one of these guys. So P0 to there, P1 to there, P2 to there, that's nice and tidy. Okay, and now now I might need to employ another board. I might run out of instructions, I don't know at this time, but I'm just going to crack on anyway. So if it's greater than 4, then we're shutting everything off, so we need to move 0, 0, 0 to x3. Then we can sleep. I'm going to put a label on there for end as such. I don't know whether it's going to format that for me or not. Okay, now if we're not doing a check, we are looking for a keep alive, so test equal x0. Now we're going to run into a problem here, so I'm going to move, so I need to preserve the value, move x0 to dat, and then I'm going to test dat is -999. Then I'm going to test dat here for -1. If it is, then I'm going to jump to sleep, because I don't care about that, and we've already catered for the negative situation there, where we're saying you know, reset the tick. Otherwise we're going to do some other stuff, and I don't need to put a negative thing on here, because now what I need to do is understand the next packet, I guess. So the first packet is whether it's on or off. So now I need to read the next packet, which is going to tell me which thing. And this is where it's going to get complicated. I think I'm going to need another board. Yeah, because I need to manage state on each of the power outputs. And the problem is always number of pins. So what I want to do is basically I want to send a sequence of packets to this thing. DST works on AC anyway, so if I use DAT there, yeah, to set 0, I don't need to worry about anything else. Otherwise we're in the on state, and we can just say DST DAT 1, and then we just need some final thing. I don't think I need to sleep there, so because I've got a sleep up here, so here I just want to move that to x3. Now, let's see if that's even close to working. Okay, that's looking like it's working so far, but then it's not doing a whole heap of stuff. Right, now we're getting our first value. It's not going to be that, so we can reset the counter. And then, is it -1? No, so we're going to move the value into there, and we're going to move that into dat. And then we're going to test. Oh, I've got a problem there already. That needs to be dat just there. Let's try that again. Okay, so yeah, moving 1 into there, which we then move to dat. And then we sleep again and we wait for our next value, which we then move to dat. And we're jumping to on because it was a value of 1, and we're going to dst dat 1, so that's address 1, so that should become a 10, which it does, and we're going to move that over there, and power 0 goes, why has that become 100? Because I moved the wrong value to x3, that's why. There we go. Right. Yes. Yes. Ah. So the turning off isn't working for some reason. Let's try this again. Let's go through and figure out why. So now we've got a value coming in. Jump to check, sleep 1. Right, here we go. So there's a -999 hidden in behind that 2 there. Now we've got 0, which we're resetting the counter. Is it -1, which it is not? Then we're going to move that value across, and we're going to move that into dat, which means that we're not jumping to on. We should just DST. Ah! Okay, that's the problem. We now need to jump to the end. Because otherwise we're overwriting that with a 1. Okay, let's try again. Okay, that's looking a bit better. Let's hit the go button and see if it all works. Oh no. Oh no. Why is that happening? Why is it sending all of them? Right. 5 sleeps. Oh. Oh. Right. Okay. We've got a problem in that this board on the left, the first, or the receiving board, understands when to reset all of these, but unfortunately this one isn't getting the signal. Okay, so if I send out say neg1 to x2, and then here I can have a little instruction that says test equal dat neg1, and then if it is, I can turn everything off by saying move 0 to ac, and then jump to end, and that should hopefully reset everything until I get another input. Let's have a look. Let's see if that works. Right, why is that failing now? Okay. We're moving 1. Oh, right, okay. I'm being stupid. So we need to have some pluses in there. There we go. That's better. Okay, that bit's working. And then verifying the sleep timeout. Why has that not kicked off? Right, let's try again. I'm going to get to here. Actually, no, here, because this is our last value that we receive. I'm going to step okay, so ACK has been reset to 0. Fine. Now we're going to add 1, add 2, add 3, add 4, and add for 5. Jump to check. Is it greater than 4? Yes it is. Move neg1 to... oh my god. It helps if I actually wire up the stuff correctly. Right, let's try this again. Alright. 1, 2, 3, 4, 5. Step. Proper job. Okay, it's all flatlined. Now we get a 1. And that turns that one high. Now we get another one. Turns that one high. Okay, I'm just going to simulate now. There we go. Alright, so production cost is on the average side. Power usage is on the higher to average side, and lines of code is on the just downright outrageous. I don't know what I'm doing wrong with these things. There's obviously some trick to doing these electronic things that I do not know, and therefore can't leverage them right now. Anyway, let me know in the comments if you want to see me do redo some of these puzzles with more efficient designs, and I will attempt to figure out where I'm going wrong with them. But otherwise, for now, I shall crack on. Now, responses to that design? Sweet, can't be too careful when you make robots. Am I right or am I right? I am learning some more casual style English from Joe. Don't learn it from Joe. That's a bad move, learning from Joe. And Carl says, you scared me for a second there, Jay. Okay, let's move on to the next thing. Control router, important. So Lily Wu, I'm pleased to say we have been selected for another Sun Haotian project, a simple data router for smart grids. Mr. Sun was never interested in civic infrastructure before, to my knowledge, but so I really wonder what he's planning. I may ask around. My uncle's had dinner with him once or twice. We can do it, says G. Note, these X-bus inputs are blocking, so we will need to connect all inputs so they can be read at once, simultaneously. Okay, how are we going to do that then? Have I got a new part to play with? SGCRD1. Let's get stuck in. What the heck is this all about? Meter in and meter out are X-bus inputs, that's here and here. Inputs and outputs that connect this node to a building's smart grid power meter. Lower in and lower out are X-bus inputs and outputs that connect this node to with a lower ID number. Huh? lower ID number. Alright, lower in, lower out. Okay. Higher in, higher out are XBus inputs and outputs that connect this node to a node with a higher ID number. Right. The first value in a data packet is the ID number of the destination and indicates how the packet should be handled. Okay. ID less than meter ID, retransmit data packet to lower node. ID equals meter ID, retransmit data packet to the meter. Greater than meter ID, retransmit data packet to the higher node. Right? Say what? The local ID number of the node is stored in a secure identity chip that can be read as an XBus input. The second value in a data packet is the length of the rest of the data packet. So you would have to basically have this nonsense on every pin. Let's get this out of the way right now. I do not care for it right now. Okay. Let's just do this for a minute. SLX, X0, move X0 to AC, and then do whatever. And let's just do the same on every single thing. And let's have a look at the verification here. Yeah, these are the packets. 5 data packets, 5 data packets, 4 data packets, 3 data packets. Okay, so yeah, this is routing info. Okay, but we're not getting values coming in at the same time across different inputs. So effectively I can just use one board to shortcut all of that, hopefully. So let's... Oh no, because they block. Right, okay, so that doesn't work, does it? See, what I'm proposing to do is use a pin to determine that we're okay to transmit off this particular board. Right? Actually, do I need to worry about this board now? I don't think I need that board anymore. Just do that. And then we can say I'm going to sleep on this. And then I'm going to move that into DAC and move the next one into AC. Then I'm going to check the compare, right? Now, if it's greater than, we're going to move 100 to P1. Okay? And then what we're going to do is in here, instead of any tests or anything like that on the pins, on the XBus, we're just going to say, forget that. We're going to move X0 to AC, and then we're going to test equal P1 100. Okay? If it is, then we're just going to move AC to X1, right? And we don't care about anything else after that. Then we just go back to sleep again. If we get a value, then we move it to AC. We test whether we're still okay to transmit. Okay, right. Now I just need to copy that down to here, down to here. Now, if this is 50, then that's the meter. If this is 0, that is lower. Now, over here, we then need the negative statement which says that it's lower, and we need to move 0 to P1, and then we need to have some jumps in there. Okay, jump to loop, jump to loop, and then here, if we get to here, we're moving 50 to not 40, we're moving 50 to P1. Okay. Then we'll get into the loop and decrement our counter. Okay, but before we do that, we've got a bunch of stuff. Now, I'm going to label that start. We don't need an end, we can do start. And then we need to move dat to x0, move ac to x0, then loop. But then we can't. SP is start loop, right? Okay, and then we need to do SP there, SP there. Okay, so that initializes our loop bit, and then we can just start sending data. This over here is waiting for data. When it does get data, it then checks what the pin says, and then we just move the value across. I'm hoping that is some ways to being correct. Let's just try it. Heart not sleeping. Why are we not sleeping now? I guess I could use maybe I can use one of these as a router. And I can say so x2 to x0, that's the data channel, and then x2 to x1 is the flag channel, and we can say move 3 to x2, move 1 to x2, x2, move 2 to x2, and then we can SLX on x1, and then we're running out of space again. However, we're not listening on x2, so maybe we can just make use of that. So 1, 2, 3, low, medium, or high. And then I can say that. Just move. Oh, come on. Move x1 to ac. And then I can loop maybe, test compare, I guess, and then I could say compare to 2, which is the mid value. If it's test ac, no, hang on, which, yeah, test ac compared to 2. I guess I need to SLX x0 at this point. If that is the case, then we are moving x0 to higher, so that's x3. Otherwise, we're moving x0 to x1. We're going to need a jump loop. I might need a bigger board, and then we need to jump loop there. Otherwise, we're just starting again. But how do we know when we're finished? This is the problem. I don't have enough instructions in here to send out a, well, you're finished now. I think what I could do is go back to my pin idea, but use it with just the one board. Now, if P1 is 0, we're not going to do anything. We're going to sleep for 1, jump. Jump to the start. Otherwise, we're going to sleep on x0, and then we're going to say test equal p1 and 3. So that sets up the kind of information that's in here. If I now move that up there, so we get that. And then we start doing the kind of moving of data. Move dat to x3, move ac to x3, then loop less ac1. Just copying this over from the other one, jump to start because we're resetting, otherwise what, move x0, no, x1 to x3 and just sequence. Right, so then we need to reinterpret the values over here and then change it so that we're always sleeping. We can't do that bit. Okay, let's do that. And then we're going to say test compare to 2. If it's higher, do this. If it's lower, do that. Otherwise, do that. I mean, that should... that kind of should make sense. I don't know. Let's have a look. Okay, so that's failing immediately. Why is that? What the hell is going on there? Let's go to there. Step. Move that there, move that there. So we've got 596 in DAT and 4 in AC. And then we're going to compare. We're going to reset to 0. And then it is 0 anyway. So now we're going to move DAT to x3. That's sleeping. And then we're going to test P1, which is 0. Ah, right. 0, right. So it's 0, 1, 2 now. So the compare is different. So compare 1. If it's greater than 1, it's going to higher. If it's less than 1, it's going to meter. Otherwise, it's going to lower. Okay, we have to kind of turn it on its head a little bit, or kind of. Let's have a look now. Oh, it kind of was there. Right, what happened? So we're doing this. We're now moving that over there. That works. Okay, now we're moving to x2, which is meter, which is correct. Then we're going to jump to the loop and wait. And we're receiving 4. We're testing the power again. And we are then sending to x2 again. That's fine. Now jump to the loop. Why is this jumped all the way back to the start? Because I'm an idiot. I didn't put a loop jump in there. Right, let's try this again. Okay, that's still failing. Why? x1 to x3, then loop. We're not sleeping. We're not sleeping on it. Do we need to sleep there? The value should just be there. Let's just try. Advance, step. We know this bit works. Okay. Test less than. It's not, for goodness sake. Wrong sign. That's what the problem is as well. Right, let's try it now. Ah, for goodness sake. Part not sleeping. Which part? Okay, 596. 4 goes. Yeah, so 81 should be coming in, which it does. Move x0 to x2. That's fine. 70, 62, and 17. Right, jump to loop, sleep there. Oh, for goodness sake, I'm not... Sub. I'm missing instructions over here because I've been messing about with it. Right, okay. There we go. Right. Now it works, finally. There we go. Bang on with the money, bang on with the power usage, and average with the lines of code. Now, let's read the emails again. I just wanted to check that I couldn't reduce the cost a little bit more. So Lily Wu says, this is just the tip of the iceberg. Mr. Sun is apparently pulling in a lot of resources and groups to create various subsystems for something. Nobody knows what it is other than it's going to be very big and potentially very lucrative for the firms involved. We're on a path to further our good relationship with his group and eventually become trusted partners, so let's continue to do our best work here. Lily Wu. Right, I want to reopen this design a minute. And, oh, hang on a minute, let's go back here. So the lines of code, I don't think I can better, but I'm wondering if I can reduce the cost. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I can't reduce it because I'm using all 4 slots and a pin. No, there's no way I can get that down any lower there. So quite how people did this with less lines of code, I really have not a clue. I just can't see it myself. I'm not going to dwell on it. I thought I perhaps could drop a board, but then I remembered that the number of inputs and outputs would screw me over. Okay, well, I'm going to call it there for this episode of Shenzhen IO. I hope you enjoyed it. If you did, don't forget to hit like, share and subscribe, and I shall see you all in the next episode. Thanks for watching, and bye bye for now.